Welcome to the course Design of Machine Elements. In this lecture, we are discussing about stresses in screwed fastening due to static loading. So, a screwed fastening or a threaded member, for example, a nut and bolt, is subjected to different types of stresses. So, there are different types of loads acting on these threaded members. So, that different types of loads include initial stresses due to tightening, stresses due to external forces, and stresses due to combined force. Initial stress due to tightening means, so if you want to join two members together using a nut and bolt arrangement, first we have to make a hole in the both members, and through that hole we are inserting the bolt, and using the nut we are tightening. So we are tightening the nut. So when we are tightening, some forces are acting on the bolt, and due to these forces there will be some stresses induced. This is known as initial stresses due to tightening. In addition to the initial tightening load, the threaded members of screwed fasteners are also subjected to some external forces. So what are these external forces? So external forces depends upon the application where we are using the threaded member. For example, consider a chair in which we are using some bolt and nut arrangements. So when a person sits on that chair, the weight of that person will act as an external force on these bolts. So depending upon the application, the bolts will be subjected to varying forces. So we know that the nut and bolt arrangement or a threaded fastener arrangements are widely used in different machines, different structures, etc. So all these machines and structures are subjected to some various loads. So due to these external loads, the stresses will be induced in these members. So the combined effect of initial tightening load and external force are considered as combined forces, stresses due to combined forces. So in most of the cases, the bolts will be subjected to initial tightening load as well as some external forces. Now we are first studying about initial stresses due to tightening. How initial stresses are developed in a bolt. With the help of a video, we can analyze the effect of tightening a nut. Now consider this video. Here you can see two parts are joined using a threaded member. So the nut is turned using a spanner. So as we are tightening the nut, what is happening? As we are tightening the nut is compressing these two joining surfaces. So the joining surfaces will exert an equal and opposite force on these nuts. So in effect, the portion between the two nuts, you can see there are two nuts in this figure. The portion between these two nuts are under tension. So when we are loosening the nut, the tensile force reduces. When we are tightening, what happens is the portion in between these two nuts will be under tension. So what will happen when we are increasing the load? When the tightening load is increased, you can see from this video. Now that as the force increases, the material behaves in an elastic manner, and when we are increasing the tightening force, we are further tightening the nut. So what will happen? The material in between the two nuts will undergo the plastic deformation and it will fail. So once again we can see during tightening, first it is undergoing elastic region. Again if you are tightening, what will happen? at last it will fail. The bolt will be broken due to failure. Okay, so when we are tightening a bolt, what is happening is, when we are tightening, the two parts will be joined together, and the two parts will exert an equal and opposite reaction in the two nuts. So we can see that there are two nuts at the both ends. So these two parts will exert an equal and opposite force on the nuts, and the portion of bolt in between that two nuts will be under tension. So we can understand that due to initial tightening, there will be an initial tensile load or initial tightening load is acting on the bolt. Due to this, there will be a tensile stress induced in the bolt. So the tensile stress due to stretching of bolts, the tensile force in a bolt due to tightening is calculated by an empirical relation. So that relation is given as Pi is equal to 2840D. So this Pi equal to 2840D is an empirical relation for calculating the initial tensile force in a bolt due to tightening. So Pi is the initial tension in a bolt. So when we are tightening a nut using a spanner, an initial load is acting on the bolt. That initial load is known as initial tension. That initial tension can be calculated using an empirical relation. Pi is equal to 2840D, where D is the nominal diameter of the bolt in mm. D is the nominal diameter in mm, and Pa is the initial tension in the bolt in Newton. So Pi is the initial tightening load that is acting on that bolt. Due to the initial tightening force, there will be initial tightening stress. Now, so this Pi is equal to 2840D suggests an initial load for making a joint fluid tight, like steam engine cylinder cover joints. So what is a fluid tight joint? So generally we know that a bolted joint is used for connecting two parts. But fluid tight joint means there should not be any fluid leakage through that joint. For making a joint fluid tight, we have to make sure that the joint is perfectly tight. That is, we have to maximum tightness should be given. Okay, for example, steam engine cylinder cover joint. So in a steam engine cylinder cover joint, the joint should be fluid tight. Why? Because otherwise the steam at higher pressure will escape through the joint. So this equation Pi equal to 2840D equation is used for making fluid tight joints. That is, for making fluid tight joints, we have to tight to a maximum. Under that condition, the initial tightening load will be calculated using Pi is equal to 2840D. So in other cases, that is other than fluid tight joints, so in some cases we don't want to make the joint as fluid tight. Okay, so just we have to join two parts together. That may be our A. In that cases, we will take the initial tightening load as half of this value. Instead of 2840, we will use Pa is equal to 1420D. So for if the joint is for fluid tight applications, or if the joint is fluid tight joint, the initial tightening load is 2840D, and for other applications other than fluid tight joint, the initial tightening load is Pa is equal to 1420D, where D is the nominal diameter of the bolt. Now this shows, consider this as a fluid tight joint. Suppose there is two pipes. The two pipes are joined together with the help of nuts and bolt arrangement. If you want to make this portion, you can see this area, we are using some gaskets to prevent the leakage of fluid. If you want to make this as a fluid tight joint, there should be a maximum tightness should be there. So we have to tighten the maximum. That is a case of a peculiarity of a fluid tight joint. So if you are using this pipe, you join for other than fluid tight applications, the tightness should be, we can reduce the tightness. But there is a problem while we are using bolts for fluid tight joints. If we are using fluid tight joints, we are making fluid tight joints, the bolt size should be greater than M16. So we have studied about designation of screw threads. M16 means nominal dia 16 mm. Nominal dia is 16 mm. So if you are using an M16 bolt, that means the nominal diameter is 16 mm. So if you are using small diameter bolts for, if you are using smaller diameter bolts for making fluid tight joints, what will happen? We know that for making fluid tight joints, we have to supply an initial load. The initial tightening load is PA is equal to 2840D. So when we are supplying this much large amount of force, there is a chance that the bolt may fail. As you have seen in the previous video, if you are increasing the tightening load, at last the bolt will fail. So to avoid that failure, the bolt diameter should be large. So for making fluid tight joints, we are using bolt size greater than M16. Therefore, bolts of size less than M16 are not permitted in making fluid tight joints. Now we can see that for tightening a bolt, we have to supply some torque. Using spanner, we are applying a tightening torque. Now here there is another empirical formula for calculating the initial tightening torque required for making a joint tight. So if you are using a nut and bolt assembly arrangement for joining two parts, we will insert the bolt, and using the nut we will tighten that joint. So using a spanner we will be tightening. So what will be the initial tightening torque? Actually, using normal calculation we can't calculate the initial tightening torque. So we are using an empirical relation. TA is equal to CD into PA by 1000. Whereas PA is the initial tension in the bolt in Newton. That we already discussed. D is the nominal diameter of bolts in mm, and C is a constant. The value of C depends upon the lubricating condition of the thread. For lubricated threads, the value of C is 0.18, and for unlubricated threads, value of C is 0.2. Now we have to calculate the tensile stress induced due to initial tightening load. If Pi is the initial tightening load and A is the area of cross section, so we have Pi as the initial tightening load. So we have an empirical relation for calculating Pi. Pi is the initial tightening load. We know that Pi is the initial tightening load. Pi by 4 DC square, where DC is the core diameter or root diameter or minor diameter. So DC is also known as core diameter or root diameter or minor diameter. Its relation with the nominal diameter is 0.84D. For example, if M20 is the bolt, we have 20 as the nominal diameter, D. This is D, small letter D. And we will get core diameter By multiplying the nominal diameter with 0.84, we will core diameter. So area of cross section of the bolt is pi by 4 dc square, and that is A, and the tensile stress induced sigma T is equal to Pi by A, where P is the initial tightening load. Now we have a question here. Determine the safe tensile load for a bolt of M24. If safe tensile stress is 40 megapascal, take the cross sectional area as 353 mm square. Here we are using a bolt designated as M24, and the safe tensile stress is given as 40 megapascal. Safe tensile stress sigma T is equal to 40 megapascal. Okay, what is the safe tensile stress? Under operating condition, the maximum stress that can be induced in the bolt is 40 megapascal. So we have to apply a load in such a way that the stress should not increase beyond 40 megapascal. The cross-sectional area is also given. As 353 mm square. Cross-sectional area is also given. Now, what we have to find out? We have to find that safe tensile load. So we have the basic equation. Stress is equal to load by area. Okay, or we can write sigma T, safe tensile stress, is equal to P by A. P by A. Okay, so using this equation, here we have sigma T is a known value 40 megapascal, or the megapascal is also is equal to 40 Newton per mm square. 40 Newton per mm square. Sigma T is equal to P by A. So what will be the safe load? How we will calculate safe tensile load? Multiply sigma T with A. P is the load. So safe sigma T into A. What is sigma T? 40 Newton per mm square into 353 mm square. So 14,120 Newton. This is the safe tensile load that can be applied on the bolt such that the induced stress will not exceed beyond 40 megapascal. So in the coming classes, we will be dealing with more number of problems. Okay, thank you.